in precisely 48 hours. At 6 minutes past midnight, Coordinated Universal Time, an extraordinary event will occur. A mysterious object, having traveled for a staggering 7 billion years through the vast emptiness between the stars, will reach the closest point it will ever come to Earth. At this exact moment, something remarkable is happening. 23 nations on Earth are participating in the largest planetary defense drill ever conducted in recorded history. Let that sink in for a moment. The timing is so exact, so perfectly aligned. It almost seems like fiction. But this is no story. This is December 17th. 2025. And the interstellar visitor known as 3 Atlas is now closer to Earth than it has ever been to any world in our solar system. The next 72 hours could potentially change everything we thought we knew about our place in the cosmos, about the objects that drift between the stars, and what our governments have quietly been preparing for while the rest of us were unaware. But before we dive deeper into what is happening right now, make sure to like and subscribe to stay updated on this extraordinary event. Now, let's take a closer look at the situation unfolding above us. As of now, 3 Atlas is 269 million kilometers from Earth. To put that in perspective, that's about 8 times the distance between our planet and the Sun. It sounds far, and in human terms, it is impossibly distant. However, in cosmic terms, this object is practically brushing against our doorstep. This marks the closest any confirmed interstellar object has ever come to Earth during a time when we have the technology to properly study it. The first interstellar visitor, Oumuamua, caught us completely off guard in 2017. By the time we realized what it was already speeding away, leaving us with nothing but questions and controversy. The second, Der Borisov, was more like a conventional comet, offering fewer mysteries but also fewer opportunities for investigation. 3 Atlas, however, is different. Unlike the previous interstellar objects, 3 Atlas arrived with enough time for us to focus every major telescope on it. Hubble has been tracking it. The James Webb Space Telescope has its sights trained on it. The European Space Agency directed its XMM Newton X-ray observatory toward it for 20 consecutive hours. Mars orbiters captured it as it sped past the red planet at a distance of 19 million miles. Even spacecraft on their way to Jupiter have redirected their instruments to gather as much data as possible before this visitor disappears forever into the vastness of space. But this is where the story takes an even stranger turn. On November 27th, 2025, just 3 weeks before its closest approach, the International Asteroid Warning Network initiated what officials are calling the largest planetary defense exercise ever conducted. This is not a simulation run in some lab. This is a live, real-time global operation involving NASA, the European Space Agency, the Japan Aerospace Exploration Agency JAXA, the Indian Space Research Organization ISRO, the China National Space Administration CNSA, and 19 other countries. Over 80 observatories around the world have been enrolled in this campaign. Ground telescopes in Hawaii, Chile, Australia, and Spain are feeding continuous data into a unified tracking network. Spacecraft in the inner solar system are also contributing their observations. According to official statements, the purpose of this exercise is to test how quickly humanity can detect, track, and coordinate a response to a high-velocity, near-Earth object. And the object chosen for this test is 3 Atlas. Let's be very clear about this. The official stance from every major space agency is that 3 Atlas poses absolutely no threat to Earth. It will pass at nearly twice the distance between Earth and the Sun. There is no trajectory that brings it anywhere close to an impact. The planetary defense drill is simply an opportunity to test how quickly humanity can detect and respond to a real, moving target. This explanation is entirely plausible, and it makes perfect sense. If you have an interstellar object passing through your solar system, why not use it to stress test your detection and response systems. However, there is something about the sheer scale of this operation that raises questions. The European Space Agency has recently secured a historic 22.1 billion euro budget, a significant portion of which has been allocated to what they term space resilience initiatives. ESA officials have stated publicly that planetary defense is no longer science fiction, but a critical skill to be honed, explicitly referencing the 2029 flyby of the asteroid Apophis, an object that will pass close enough to Earth to be visible to the naked eye, as a driving motivation behind these preparations. The ongoing drill involves not just tracking and observation, but also simulations of deflection missions inspired by the DART test, civil defense mobilization protocols, and public communication strategies. The last of these is especially interesting. Why is international coordination necessary to prepare public communication strategies for a planetary defense scenario? What exactly would we say to the public in the event of a planetary defense crisis? I'm not suggesting that anyone is hiding an imminent threat, but I do believe that the authorities involved in this operation are taking this moment very seriously, perhaps more seriously than their public statements would suggest. When 23 nations simultaneously activate their space defense infrastructure around an object they insist is completely harmless, it's worth considering what else they might be learning, what simulations they might be running, and what capabilities they might be testing that extend beyond the immediate visitor but are critical for future threats. Let's look at the trajectory of 3 Atlas for a moment. This object entered our solar system from the direction of the constellation Sagittarius, near the galactic center. It has been falling toward our Sun for longer than our solar system has existed. The latest estimates suggest it formed approximately 7 billion years ago, almost 3 billion years older than Earth itself. For billions of years, it has been drifting through interstellar space, exposed to cosmic radiation, accumulating damage and transformation on the molecular level. When it finally crossed into the gravitational influence of our Sun, it began accelerating, picking up speed as it fell inward. By the time it reached perihelion, its closest approach to the Sun on October 29th, it was traveling at an incredible 246 km/h. This is the fastest any object of this type has ever been clocked in our solar system. Now, having whipped around the Sun, it is heading back out toward the void, carrying with it whatever secrets it holds from the distant past, from the time before our world even existed. In just 48 hours, precisely 6 minutes past midnight, Coordinated Universal Time, an object that has traveled through the vast emptiness between the stars for 7 billion years will make its closest approach to Earth. At that very moment, 23 nations across the globe will engage in the largest planetary defense exercise ever conducted in human history. This timing is so remarkably precise, so perfectly aligned, that if it were a plot in science fiction, the editor would tell you it's too improbable to believe. But this is no fiction. This is December 17th. Liantianling and the interstellar object known as 3 Atlas is now closer to Earth than it has ever been to any world in our solar system. What happens in the next 72 hours could potentially reshape everything we thought we knew about our place in the universe, about the objects that drift between the stars, and about the preparations our governments have been quietly making, while the rest of us have been unaware. But before we dive deeper into what is unfolding above us, make sure to like and subscribe to stay updated on this extraordinary event. Now, let's take a closer look at what is happening right now. As of today, 3 Atlas is 269 million kilometers from Earth. To put this into perspective, it's roughly 8 times the distance between Earth and the Sun. It sounds distant, and in human terms, it is almost impossibly remote. But in cosmic terms, this object is practically at our doorstep. This is the closest any confirmed interstellar object has ever come to Earth during a time when we possess the technology to study it properly. When Oumuamua arrived in 2017, it caught us completely off guard. By the time we realized what it was already racing away, leaving behind only questions and controversy. The second interstellar object, Borisov, behaved more like a conventional comet, offering fewer mysteries but also fewer opportunities to study. 3 Atlas, however, is different. 3 Atlas arrived with ample warning, giving us time to focus every major telescope on it. Hubble has been tracking it. The James Webb Space Telescope has its sights trained on it. The European Space Agency directed its XMM Newton X-ray Observatory toward it for 20 consecutive hours. Mars orbiters captured it as it sped past the red planet at a distance of 19 million miles. Even spacecraft on their way to Jupiter have reoriented their instruments to gather as much data as possible before this visitor fades into the void of space. But this is where the story gets even more intriguing. On November 27th, Liaotianling just 3 weeks before its closest approach, the International Asteroid Warning Network launched what officials are calling the largest planetary defense drill ever conducted. This is not a simulation run in some lab. This is a live, real-time global operation involving NASA, the European Space Agency, the Japan Aerospace Exploration Agency, JAXA, the Indian Space Research Organization, ISRO, the China National Space Administration, CNSA, and 19 other countries. More than 80 observatories worldwide are involved in this campaign, with ground telescopes in Hawaii, Chile, Australia, and Spain feeding continuous data into a unified tracking network. Spacecraft in the inner solar system are also contributing their observations. The official statement is that this exercise is designed to test how quickly humanity can detect, track, and respond to a high-velocity near-Earth object. And the object they've chosen for this test is 3 Atlas. Let's be clear about one thing. The official position from every major space agency is that 3 Atlas poses absolutely no threat to Earth. It will pass at nearly twice the distance between Earth and the Sun. There is no trajectory that brings it anywhere near an impact. The planetary defense drill is an exercise to test how quickly humanity can detect and respond to a real, moving target. This is entirely plausible and makes perfect sense. After all, if an interstellar object is passing through your solar system, why not use it to test your detection and response systems? But there is something about the scale of this operation that raises questions. The European Space Agency has secured a record €22.1 billion budget, a significant portion of which has been allocated to what they call space resilience initiatives. ESA officials have stated publicly that planetary defense is no longer science fiction but a critical skill to be honed, explicitly referencing the 2029 flyby of asteroid Apophis, a potentially visible object, as a driving motivation for accelerating these preparations. The current drill involves not just tracking and observation but also simulations of deflection missions, civil defense mobilization protocols, and public communication strategies. The last element is particularly interesting. Why are they practicing public communication strategies for a planetary defense scenario? What exactly would we tell the public in the event of a planetary defense crisis? I'm not suggesting there's an imminent threat. The orbital mechanics of 3 Atlas are well understood and confirmed by multiple independent observations. It will pass harmlessly by. But I am suggesting that the authorities involved in this operation are taking this moment far more seriously than their public statements might suggest. When 23 nations simultaneously activate their space defense infrastructure for an object they insist is completely harmless, it's worth considering what else they might be learning, what scenarios they might be preparing for, and what capabilities they might be testing that go beyond this one object but are crucial for future threats. Let's take a moment to consider the trajectory of 3 Atlas. This object entered our solar system from the direction of the constellation Sagittarius near the galactic center. It has been traveling toward our Sun for longer than our solar system has existed. Estimates suggest it formed 7 billion years ago, almost 3 billion years before Earth itself. For billions of years, it has drifted through interstellar space, gathering cosmic radiation, accumulating damage, and undergoing molecular transformation. When it finally crossed into the gravitational influence of our Sun, it began accelerating, picking up speed as it fell inward. At perihelion, its closest approach to the Sun on October 29th, it was traveling at an astonishing 246 nulla km/h, making it the fastest object of its type ever clocked in our solar system. Now, having passed the Sun, it's heading back out toward the vastness of interstellar space, carrying with it whatever secrets it holds from a time long before Earth existed. 3 Atlas presents challenges that are pushing our current capabilities to the limit. Its coma is massive, stretching hundreds of thousands of kilometers in multiple directions. It boasts an anti-tail, pointing directly at the Sun, something that defies conventional physics. Its jets are erupting asymmetrically, creating irregular brightness patterns, and it is moving faster than any comet we've previously tracked. This makes small errors in its position have large repercussions in predicting its trajectory. If the International Asteroid Warning Network, IAWN, wanted to test their ability to track an extremely difficult target, they could not have designed a better one. However, this exercise goes beyond just astrometry, which is the precise measurement of an object's position. Documents and statements from the participating agencies show that the campaign also includes orbital prediction drills. These drills are designed to test how quickly the teams can refine trajectory estimates as new data comes in. It also involves anomaly response protocols, what to do when an object behaves in ways we don't expect. There are multi-agency coordination exercises, testing how fast organizations like NASA, ESA, JAXA, and others can communicate, exchange information, and make decisions under conditions of uncertainty. One of the most intriguing aspects of the exercise, though, is the focus on public communication. Why, you might ask? Does a planetary defense exercise need to practice managing public communication? The obvious answer is that any real threat scenario would create enormous public interest, and agencies would need to communicate clearly and effectively to avoid panic. However, the inclusion of misinformation management suggests something more. It suggests that officials are preparing for the kind of narrative chaos that has already surrounded 3 Atlas claims of alien spacecraft. Speculation about trajectory changes, rumors of cover-ups, and debates over hidden data. This part of the exercise is likely aimed at preparing officials for the challenge of dealing with competing narratives, especially as they may try to counter misinformation that could undermine public trust in official assessments. The timing of this planetary defense preparation is not coincidental. The European Space Agency has openly referenced the 2029 flyby of asteroid Apophis, which will pass within 31.0 kilometers of Earth, closer than the orbit of our geostationary satellites. As the driving motivation for accelerating planetary defense capabilities, Apophis is well understood and poses no threat, but it's a known quantity. In contrast, 3 Atlas represents an entirely different kind of challenge, something that tests our ability to respond to unexpected events. Objects arriving from unknown directions, at high velocities that compress our response time to nearly nothing. When 3 Atlas was first identified on July 1st, we had less than 4 months of warning before it reached perihelion. For an object moving at its speed, that's practically no time at all. Researchers found that launching a spacecraft to intercept 3 Atlas would require a change in velocity of at least 24 kilometers per second, an amount of energy no existing propulsion system can achieve. If this object had been on a collision course with Earth, we would have had no way of deflecting it. We could have seen it coming, but that's all we would have been able to do. This is a scenario planetary defense officials don't often discuss publicly, the scenario where detection comes too late. The object is too fast, and all our preparations are powerless. The 3 Atlas campaign is not just about tracking a comet, it's about testing the limits of our current planetary defense systems, identifying the gaps in our detection networks, and preparing for a future where objects like this don't catch us off guard. In this context, The European Space Agency has deployed new systems that are central to global early warning strategies. The first, known as MERCAT, is a ground-based network designed to scan large areas of the sky for faint, fast-moving objects. The second, EGIS, is a space-based component that will eventually cover regions that ground telescopes cannot continuously monitor. These systems are not yet fully operational, but the 3 Atlas campaign is providing real-world data to help calibrate their parameters. Every observation of this interstellar visitor is teaching us how to detect and track the next one. And there will be a next one. Current statistical models suggest that approximately 10,000 interstellar objects pass through our solar system at any given moment. But so far, we've only detected 3. The Vera Rubin Observatory, the most powerful survey telescope ever built, is set to begin operations within the next year. It's expected to discover, on average, 1 new interstellar object per year. Within a decade, we could have dozens of these visitors catalogued. Each one will be a test case, an opportunity to refine our understanding of what drifts through the space between the stars. The ongoing planetary defense drill will continue until January 27th. 2 full months of continuous observation, coordination, and analysis. By the time it concludes, 3 Atlas will be well on its way out of the inner solar system. But the lessons learned will stay with us. The relationships between agencies will continue, and the protocols tested during this exercise will become standard operating procedures. More importantly, the data collected over the next few weeks may hold the key to understanding how we prepare for future cosmic encounters. I want to be clear here, I am not suggesting that 3 Atlas itself poses any threat to Earth. Every credible analysis confirms that it will pass by safely. Its trajectory is well understood, and there is no scenario in which it will impact Earth or any other planet. What I am suggesting is that the response to 3 Atlas reveals something important about how seriously our institutions are taking the broader issue of planetary defense. The activation of 23 nations' space defense infrastructure for a routine observation is not something that happens every day. The record budgets allocated to resilience initiatives are not because everything is fine. The language used by officials, terms like no longer science fiction and critical skill to hone, carries weight. These are not just bureaucratic phrases. They reflect a deeper understanding that preparation is not optional, especially when future objects might behave very differently from 3 Atlas. The preparation we're witnessing now is laying the foundation for how we will respond to the next interstellar visitor, whatever form it takes. The lesson here is not just about tracking an object from the stars. It's about recognizing the need for constant vigilance, innovation, and global cooperation when faced with threats we cannot predict, from directions we cannot foresee. The future of planetary defense may depend on how effectively we learn from these exercises and the data we gather now. This unusual composition of 3 Atlas is beginning to suggest that this interstellar visitor may not be like any comet we've ever encountered before. It could represent an entirely new category of object, one that was born in conditions so different from our own solar system that it has evolved in ways we cannot yet fully comprehend. The fact that 3 Atlas is emitting nickel without iron is highly significant. In our solar system, nickel and iron almost always occur together in comets, as both metals are byproducts of the same stellar processes. But here, we see a comet-like body that behaves in a way that defies these expectations. The absence of iron in the material being emitted, combined with the unique anti-tail, raises more questions than answers. What are we witnessing here? Is it possible that this object has been traveling across the cosmos for billions of years, only to now enter our solar system with secrets and properties that we cannot yet explain? Perhaps most puzzling is the persistence of the anti-tail. This feature, which points directly toward the Sun, continues to grow and evolve. It doesn't behave like anything we have seen before in other comets. It defies every model of cometary behavior. And as the object travels farther from the Sun, It remains visible, stubbornly refusing to fade. The antitail's continuous presence combined with the peculiar way it wobbles. Tracking the object's rotation suggests that the mechanisms behind it are far more complex than what we have been led to believe. The wobble of the antitail, with its regular 74-hour cycle, provides the first piece of reassurance that there might be a natural explanation after all. A traditional comet may produce jets of material in a more chaotic way, but here we are seeing something with clear periodicity. Could the antitail simply be a result of material that only vents when facing the sun, and the rotation of 3 Atlas causes it to sweep back and forth, creating this curious feature? While this is plausible from a conventional physics perspective, the fact that the antitail has persisted for so long is perplexing. Most similar features in solar system comets appear only for brief periods. What makes 3 Atlas so different? These questions only deepen when we consider the object's chemical composition. The spectral observations from the Very Large Telescope have confirmed the presence of nickel vapor in the coma of 3 Atlas. But what's curious is the absence of iron, which is typically found alongside nickel in comets. This could suggest that 3 Atlas formed in an entirely different environment, perhaps in an interstellar medium that didn't share the same elements or processes that shaped comets in our solar system. The lack of iron paired with the presence of nickel alone could mean that this object is a relic from a distant part of the galaxy, one that carries with it signatures of conditions we've never before encountered. Could 3 Atlas be an object from a star system that formed under completely different cosmic conditions, with a history stretching billions of years beyond our understanding? Perhaps it has spent its existence hurtling through interstellar space, altered by cosmic radiation and forces that have transformed it in ways that make it unrecognizable to us. But there is still another possibility that researchers are reluctant to entertain: the idea that 3 Atlas is something much more than just an object of natural origin. We are still gathering data, and the final answer to the mystery of 3 Atlas may remain elusive for some time. But as the object continues its journey away from our solar system, the window for observation is quickly closing. This is our last chance to study it, to unlock the secrets it carries with it, and when it fades into the darkness of interstellar space, we may never have another opportunity to observe something like it again. For now, the world watches as this mysterious object travels through our solar system. The data collected in the coming weeks will continue to be analyzed, and the lessons learned will shape our understanding of what lies beyond our solar neighborhood. Whether 3 Atlas is a natural object, an alien spacecraft, or something else entirely, one thing is clear: its presence has given humanity a chance to learn more about the universe than we ever thought possible. What we choose to do with that knowledge and the questions we dare to ask will determine how we prepare for the cosmic challenges ahead. The rhythmic pulsing of 3 Atlas, increasing by 20 to 40% every 16 hours, has baffled researchers since the first observations began. Initially, the fluctuations in brightness were dismissed as equipment malfunction, but after careful adjustments for factors like distance, angle, and solar illumination, the result was undeniable. The object behaves like a cosmic lighthouse, its brightness fluctuating with remarkable precision as though broadcasting its presence across the void. The most obvious explanation for this phenomenon would be a rotating, elongated shape, causing the object's surface area to be exposed at different angles, creating natural fluctuations in brightness. While this is not unprecedented in the study of asteroids, the amplitude of the variation, an extraordinary 40% change, is harder to explain. For such a dramatic change to occur, the object would need an axis ratio, suggesting an extremely elongated or flattened shape. But that alone doesn't fully account for the behavior we're witnessing. The twist comes when we look at the data from the Hubble Space Telescope. It clearly shows that most of the light emitted by 3 Atlas comes not from the nucleus, but from the enormous coma, a cloud of gas and dust surrounding the object. The nucleus is just a small part of the light we observe. If the brightness variations were solely caused by the rotation of the nucleus, The fluctuations would be dampened by the steady glow of the coma. But that's not what we see. This suggests that something else is responsible for the intense brightness changes. Avi Low, one of the foremost researchers investigating 3 Atlas, has proposed an alternative explanation. According to Low, the periodic brightness increase could be due to jets of material erupting from the surface of 3 Atlas in discrete pulses. These outgassing jets are not uniform. They erupt from specific locations on the object's surface. And as the nucleus rotates, these active regions periodically sweep into and out of the sunlight. Each time a volatile, rich pocket faces the sun, it heats up and explodes outward, sending fresh material into the coma. This burst of material scatters sunlight, making the coma appear brighter and explaining the observed fluctuations in light. This hypothesis shifts the focus of the anomaly from the object's shape to the mechanics of the jets themselves. If the periodic variations are tied to the outgassing process, this suggests that 3 Atlas is far more complex than a simple comet, and its behavior may be governed by internal processes that we've yet to fully understand. In addition to the pulsating light, the object's strange antitail adds to the mystery. No known comet exhibits such a feature, especially one so massive and enduring. The antitail, a structure extending towards the Sun, is an unprecedented occurrence in the study of comets. It's not simply a transient effect caused by the angle of observation. It persists across months, surviving perihelion and continuing into the outbound journey of 3 Atlas. Researchers, including Avi Low, have proposed various hypotheses, but no definitive explanation has emerged. As we continue to study 3 Atlas, these anomalies pile up, creating a scientific puzzle unlike any other. This object, traveling through our solar system at extraordinary speeds and with behavior so unpredictable, is forcing us to rethink what we know about comets and interstellar objects. Is 3 Atlas simply an unusual comet, a natural phenomenon behaving strangely due to conditions we don't fully understand? Or is there something more going on, something that pushes the boundaries of our current knowledge and challenges our understanding of the cosmos? With just a few more days until its closest approach, we have a narrow window to capture the data that might provide answers. As 23 nations and countless astronomers across the globe continue their efforts to study 3 Atlas, we are confronted with an unprecedented opportunity to explore the mysteries of an interstellar object, an object that, despite its fleeting visit, may fundamentally alter the way we understand the universe. But 3 Atlas is different. Unlike typical comets, which form insulating layers of dust and debris over time, 3 Atlas continues to exhibit global activity. This suggests that something deeper, more complex, is happening beneath its surface, triggering a unique form of outgassing. The energy released during the eruptions is not just the result of solar heating. It seems to be compounded by the internal chemistry of the object itself. The proposed mechanism, based on the composition of 3 Atlas, points to a similarity with carbonaceous chondrites, ancient meteorites that contain carbon-rich compounds and metals such as iron and nickel. When sunlight heated the icy surface of 3 Atlas, it didn't merely cause the usual evaporation of carbon dioxide. The heat appears to have triggered a chemical reaction with the metal grains embedded in the object's structure. This interaction released additional energy, creating a cascade of reactions that fueled the eruptions with far more force than simple solar heating could explain. The outgassing is not just a passive process of sublimation, but an active, self-amplifying system, powered by internal chemistry. This new understanding could offer insights into why 3 Atlas has remained so active and why its activity has been so persistent and global. Unlike most comets, which develop a crust that slows or halts outgassing as they near the Sun, 3 Atlas seems to be defying this pattern. Its ability to maintain such global activity across the entire surface, even after months of close solar approach, suggests that something about its composition allows it to continue erupting with remarkable intensity. As 3 Atlas nears its closest approach on December 19, Liangqianling Wu. Scientists will continue to watch its eruptions closely. High-resolution images and spectroscopic data could offer more clues about the internal processes driving these eruptions. Understanding how the object responds to solar heating and how its internal structure influences its behavior could help unlock the secrets of this strange visitor from interstellar space. In the coming days, as 3 Atlas continues its journey through our solar system, we will have a rare opportunity to observe an object that behaves in ways we've never seen before. For now, the mystery deepens an ancient traveler from beyond our solar system, revealing its secrets piece by piece as it races away from us toward the vast emptiness of interstellar space. What we learn in these final moments of observation could change everything we know about the objects that drift through the void between stars, and perhaps even the very nature of the cosmos itself. 3 Atlas's journey began in a time long before the solar system even existed. To grasp the true magnitude of this interstellar visitor, we must look back over 7 billion years, to a period when the universe itself was still in its infancy. The Milky Way was a chaotic and evolving place, constantly merging with smaller galaxies and forming stars at a rate far greater than we observe today. The stars that once illuminated the galaxy were very different from the ones we know now, and planetary systems were in the process of formation, each one a unique snapshot of cosmic evolution. During this time, 3 Atlas was already ancient, unlike our solar system, which began its formation around 4-6 billion years ago. 3 Atlas originated in a much older, distant galaxy, possibly under conditions that differ greatly from those that shaped our own solar neighborhood. It traversed the vast expanse of interstellar space for billions of years, accumulating cosmic radiation that altered its surface and composition, making it a unique relic from a time long forgotten by human history. The current estimates place 3 Atlas's age at approximately 7 billion years, plus or minus a few billion, depending on the method used. To put this in perspective, our solar system is only 4-6 billion years old. The gap between 3 Atlas's origin and the formation of the solar system is staggering, highlighting just how ancient this object is. It traveled across the cosmos, carrying with it the chemistry and secrets of a distant star system. And now, as it nears Earth, we have the rare opportunity to study it. What makes 3 Atlas even more extraordinary is not just its age or its origins, but the trail it has left behind as it enters our solar system, its interactions with solar radiation, its cryovolcanic eruptions, and its surprising chemical composition challenge everything we thought we knew about comets and interstellar objects. The discoveries made over the last few months, including its anti-tail and the regular pulsations of its brightness, offer glimpses into a reality beyond our expectations. These observations suggest that 3 Atlas may be far more than a simple interstellar object. It might be a messenger from a bygone time, carrying the imprints of a long-lost star system, a system whose story is written in the composition of the object itself. And as we stand on the edge of this unprecedented encounter, with 3 Atlas preparing for its closest approach to Earth, one thing is certain: its journey is far from over. Just as it passed through the stars of its home system, it will continue its path through the universe, eventually fading from view. We may never fully understand all the mysteries it carries, but for now, we are here, and the universe is allowing us to listen, observe, and wonder about the secrets that lie within this ancient traveler from the stars. 3 Atlas serves as a reminder that the universe is vast, ancient, and filled with wonders far beyond our comprehension. It has carried its story through time, crossing the darkness between the stars, and now, as it nears its closest approach to Earth, it opens a window into the unknown, a glimpse into a past that predates our very existence. We can only hope to glean as much as we can before it disappears into the vast expanse of space once more. And who knows, perhaps one day, another visitor will come, carrying its own story, and we will be here, ready to listen, just as we are now. The image taken by the European Space Agency's XMM Newton telescope on December 3rd, Liaozinling Arshawu, revealed something unprecedented: the first X-ray portrait of an interstellar comet. This new observation introduced a layer of complexity that astronomers had never anticipated. The image shows 3 Atlas glowing with a bright red hue against the vast darkness of space, a color indicative of low-energy X-rays. These are photons with wavelengths far shorter than visible light, carrying far more energy than anything our eyes are equipped to detect. What's perplexing is that these X-rays should not exist, as comets cold. Inert objects are not capable of generating X-rays through any internal processes. They lack the extreme conditions, such as intense temperatures or nuclear reactions, that are typically required to produce high-energy radiation. Yet here, 3 Atlas is radiating in the X-ray spectrum, contradicting our expectations. Comets generally do not emit X-rays. Their composition and behavior don't support the kind of energy emissions we typically associate with these wavelengths. The implications of this discovery are profound. What could be the source of these X-rays? Are they a byproduct of the comet's interaction with the solar wind or its environment? Or is there something fundamentally unique about 3 Atlas that challenges everything we thought we knew about cometary behavior? As astronomers attempt to make sense of this unexpected emission, the questions keep mounting. This discovery was the culmination of over 20 hours of continuous observation, capturing a moment in time when 3 Atlas was far enough from the Sun that the observational challenges of solar glare were mitigated, but still active enough to reveal these anomalous features. And as the comet approaches its closest point to Earth, with only a few more days to observe, the urgency for answers grows. What we are seeing is not just an object from another star system, it's a cosmic mystery unfolding before us. 3 Atlas, traveling for 7 billion years across the vast stretches of interstellar space, now presents an enigma that could redefine our understanding of both comets and the fundamental nature of interstellar objects. From its unusual composition to its anti-tail defying the laws of physics, to its X-ray emissions, 3 Atlas is offering a glimpse into a past that no human eye has witnessed and into the unknown mechanisms of the cosmos. The X-ray emissions, alongside the discovery of cryovolcanic activity, suggest that 3 Atlas might be more than just a frozen relic from the past. It's an object that, while ancient and remote, is still alive, with activity, its surface constantly reshaped by the solar energy it absorbs. Perhaps, like an ancient witness to long-lost worlds, 3 Atlas holds the answers to questions we have yet to ask, the clues to secrets about the universe that have been locked away for billions of years. And as the comet races towards its closest approach to Earth, our window for observation is closing. After December 19th, it will be too faint for most telescopes to track, its secrets slipping further away. In the next few days, we have the opportunity to capture the data that may unravel the deepest mysteries of 3 Atlas. But once this window closes, the object will continue on its journey, fading into the cosmos, a silent traveler carrying the imprints of an ancient time, and a reminder of the vastness and unpredictability of the universe. Avi Loeb's perspective on 3 Atlas has stirred considerable debate in the scientific community, and his stance remains a defining element in the ongoing discussion surrounding this interstellar visitor. Loeb, a prominent astrophysicist and head of the Galileo project at Harvard University, has long argued that we should not dismiss the possibility that 3 Atlas might not be entirely natural in origin. It is important to clarify, however, that Loeb does not claim 3 Atlas is definitively an alien spacecraft. Instead, he maintains that the overwhelming evidence points to natural explanations, but he believes that the scientific community has been too quick to close its mind to alternative theories. For Loeb, the question is not whether 3 Atlas is a comet, but why the scientific community is so quick to dismiss the possibility that there might be something more to the story. He has pointed out that 3 Atlas behaves in many ways like a typical comet displaying a coma, emitting gas, and following a trajectory consistent with gravitational dynamics. But it is the anomalies like the anti-tail, the periodic heartbeat-like brightness variations, and the unique X-ray emissions that suggest the object could hold answers that go beyond our current understanding of comets. Loeb argues that we must remain open to all possibilities, including the idea that 3 Atlas might be something far more intriguing than a mere cosmic wanderer. He believes that it is not enough to simply interpret the object within the framework of conventional cometary behavior. Instead, he insists that the scientific community must ask the tough questions and avoid the sociological pressures that often guide scientific conclusions. These pressures, according to Loeb, can sometimes lead researchers to close ranks around accepted theories, suppressing ideas that challenge the status quo. Loeb's position has caused a divide among astronomers. Many of his colleagues view him with a mix of respect and frustration. They respect his intellect and the depth of his analysis, but they also see his persistent questioning as a disruption to the consensus. Critics argue that the evidence for an artificial origin remains speculative and lacks the necessary support to overturn natural explanations. They contend that comets can exhibit anomalous behavior without resorting to extraordinary explanations. However, Loeb's insistence on considering alternative hypotheses has undeniably influenced the public's perception of 3 Atlas. His vocal stance has ensured that the object is seen not only as a scientific curiosity, but as a subject that challenges our understanding of what is possible in the cosmos. His work has brought new attention to the idea that interstellar objects might carry information about distant star systems that we have never fully appreciated before. As 3 Atlas draws closer to Earth, the debate over its true nature is far from settled. The next few days will provide the scientific community with a unique opportunity to gather data, analyze its behavior, and perhaps find answers to questions that have eluded us for millennia. Whether 3 Atlas is a typical comet or something far more extraordinary, the data collected will shape our understanding of the universe in ways that may reverberate for years to come. For now, as we watch this ancient traveler pass through our solar system, we are left to wonder, is 3 Atlas simply a strange comet from a distant star? Or is it a messenger from another world, carrying secrets we have yet to uncover? Whatever the answer, the questions it raises are profound. The opportunity to explore the mysteries of the cosmos is fleeting, and 3 Atlas has given us a glimpse into the unknown that may one day change everything we know about the universe. As 3 Atlas moves at an astonishing 60 kilometers per second, it provides an unprecedented test case for planetary defense systems. The object's rapid movement has pushed global collaboration to new heights, testing the capabilities of space agencies, astronomers, and scientific institutions in ways never before imagined. This moment is not just an opportunity to study an interstellar visitor, but a critical chance to refine our response mechanisms for objects that could one day pose a genuine threat to Earth. The clock is ticking, and the time to learn and adapt is now. The global response, coordinated by the International Asteroid Warning Network, IAWN, has already yielded valuable insights. The accuracy of trajectory predictions has improved dramatically, thanks to the combination of real-time data from spacecraft in orbit around Mars and Earth, as well as ground-based telescopes. The result, a precision in tracking that would have been unimaginable a decade ago, making it clear that humanity's ability to detect and understand interstellar objects is progressing at an incredible pace. But as much as 3 Atlas is being studied and observed, the real questions lie in what comes next. What happens when the next object enters our solar system, unannounced, and presents us with far less time to respond? How quickly can the data flow between agencies? And how effectively can planetary defense systems pivot when a fast-moving target appears out of nowhere? These are the concerns that keep officials in the field awake at night. 3 Atlas represents a scenario where the response has been swift, calculated, and measured thanks in large part to the lessons learned from previous planetary defense exercises. However, the next interstellar object may not provide the luxury of months of observation. This is why the global community has been working overtime, using 3 Atlas as a real-world stress test for the capabilities we'll need to defend against any future threats. The training and analysis that began on November 27th, 2025, will continue until January 27th, 2026. But the lessons learned from 3 Atlas will stay with us far beyond that window. Despite the absence of a threat from 3 Atlas, the current exercise has already demonstrated the importance of advanced tracking systems, refined coordination among international agencies, and the vital role of public communication. Miscommunication or a lack of transparency could have led to chaos. But the efforts put in place to prepare for these very eventualities will serve humanity well in the future. As the interstellar comet approaches Earth, each passing day brings new data and new mysteries to unravel. From its strange anti-tail to its heart-pulsing 16-hour rhythm, 3 Atlas continues to surprise and challenge our understanding. While mainstream science focuses on conventional explanations, the continued anomalies, such as the unique X-ray emissions and possible cryovolcanism, suggest that 3 Atlas is no ordinary comet. Whether it remains a peculiar visitor from another star system, or whether it reveals something even stranger, this visitor has left a mark on our collective curiosity. In the end, the true value of this encounter may not just lie in what we learn about 3 Atlas itself, but in how the data from its brief passage will inform our preparation for the unknown objects yet to come. As the cosmic clock ticks down toward its closest approach, 3 Atlas will continue to be observed from every angle, its every movement carefully tracked, its every secret probed for clues to its origins and behavior. When this interstellar traveler fades into the depths of space, its heartbeat may be lost to the void, but the scientific breakthroughs, the international cooperation, and the lessons learned from its passage will echo long after it has gone. For now, the world waits, watches, and wonders, and in the vastness of the cosmos, humanity is learning how to listen. However, when you look at the sequence of events, when you consider the perfect alignment of circumstances that has made this event possible, the idea of pure coincidence starts to feel insufficient. The timing, the technology, the readiness of global space agencies, the conditions in the sky, everything has come together in a way that seems almost too convenient. Here we are, in the final days before 3 Atlas reaches its closest point to Earth, and everything about this moment feels charged with significance. It's not just the object itself that fascinates us, it's the broader implications of this event. We are witnessing an unprecedented convergence of scientific preparation, technological advancement, and human curiosity. What has unfolded over the past 6 months is not just a story about an interstellar object passing by our planet, but a broader narrative about how far we've come in our ability to detect, understand, and respond to the unknown. From the moment the object was detected by the Atlas telescope in Chile on July 1st, to the detailed images captured by the Hubble and James Webb space telescopes, we've been on a journey of unprecedented observation and analysis. Each new piece of data, each new anomaly from the strange anti-tail, to the unusual chemical composition, to the rhythmic pulsation in its brightness, has pushed the boundaries of what we thought we knew about interstellar objects. The mysterious, persistent heartbeat of 3 Atlas, its cryovolcanic activity, and its X-ray emissions have only added layers of complexity to the puzzle. Then, in November, when the global scientific community was grappling with the unknowns, the United Nations International Asteroid Warning Network activated the largest planetary defense exercise in history. This exercise, involving 23 nations and spanning from late November to January, perfectly coincides with the closest approach of 3 Atlas, as if the timeline itself had been designed to test humanity's readiness for potential space threats. The world's space agencies, observatories, and scientific teams are united in a global response, observing and analyzing this interstellar visitor like never before. The exercise is not just a dry, technical test. It's a very real rehearsal for how we might one day handle an object that threatens Earth. 3. Atlas is not a threat, but it serves as a crucial learning opportunity. The information we gather, the lessons we learn, and the protocols we perfect over these few weeks will be instrumental for future encounters. The systems being tested are essential for detecting, tracking, and characterizing objects in our solar system and beyond. In short, this is the moment when humanity is learning how to prepare for the unknown, to respond to the cosmic surprises that may one day arrive on a collision course with our planet. It is impossible to ignore the profound implications of what is unfolding. At its closest, 3 Atlas will pass Earth at a distance of 269 million kilometers, a mere 8 times the distance between Earth and the Sun, seemingly distant by our standards, but incredibly close in cosmic terms. The timing of this event, coinciding with a new moon phase and optimal viewing conditions, has given us the best chance in history to study an interstellar object in detail. But as we race against the clock, it's important to remember the larger picture. What we are learning about 3 Atlas is not just about this one object, but about the nature of the universe itself. The anomalies we are studying may not just be strange quirks of one interstellar comet, but clues to the behavior of objects in space, objects that we have yet to fully understand. And the more we learn, the more questions arise. How typical is 3 Atlas? Is it an outlier? Or does it represent a new class of interstellar objects? Is there something unique about the way this comet behaves? Or are we simply seeing it through the lens of unprecedented technological capabilities? As we enter the final stretch of this event, with 3 Atlas reaching its closest approach to Earth, one thing is clear: this is a once-in-a-lifetime opportunity. The data we gather in these final days will shape our understanding of the cosmos and our place within it for decades to come. And as the comet continues on its journey into the outer reaches of our solar system and beyond, we will be left with the knowledge and insights we've gained, and the unanswered questions that will drive us to look even further into the vast, mysterious expanse of space. The coincidences I've outlined so far may indeed be just that, coincidences. They can be explained by probability, by the fact that we observe what we're capable of observing, by the selection effects that make certain events more likely to catch our attention. Yet, there's something about the alignment of these events that sparks wonder. An object older than our solar system, traveling for 7 billion years across the galaxy, arrives at precisely the right moment in human history. We happen to be at the perfect technological level to observe it, study it, and learn from it. We have instruments in space, at Mars, and on their way to Jupiter, all of which can contribute valuable data. And, most remarkably, we have global coordination mechanisms in place to share information across nations, all perfectly aligned. Perhaps this is just the nature of the universe. Perhaps interstellar objects pass through our solar system all the time, tens of thousands of them at any given moment. According to statistical models, we simply don't notice them because we lack the tools to detect them. Maybe 3 Atlas is just the first of many such visitors we'll be able to study in the coming years. And in a decade, when observatories like Vera Rubin start to catalogue dozens of these interstellar objects, we may look back on our fascination with 3 Atlas and find it quaint. After all, of course, interstellar visitors exist. They've always been there. What did we think the galaxy was empty? But for now, in December 2025, 3 Atlas feels special. It feels like a message, even if we can't read the language. It feels like an invitation, even if we don't know where we are being invited. It carries chemistry. We recognize carbon, water, and the building blocks of life. It exhibits behaviors we can't fully explain. It arrives at precisely the moment we are prepared to notice. Just as we're learning to understand what we're seeing, I don't know what to make of that. I'm not sure anyone does. What I do know is that the next 48 hours are crucial. The data collected during the closest approach will be analyzed for months, perhaps years. Researchers will publish papers debating the anti-tail, the heartbeat, the cryovolcanism, and the composition of 3 Atlas. Some mysteries will be solved, others will deepen, and eventually, when 3 Atlas fades beyond our ability to observe, we'll be left with whatever conclusions we've managed to reach. These conclusions will shape how we think about the universe, about our place within it, and about the objects that drift between the stars, carrying histories we can barely imagine. 3 Atlas is a messenger. We may never fully understand the message, but the attempt to decode it has already changed us. As I record these words, the interstellar visitor is closer to Earth than it has ever been, and closer than it will ever be again. Telescopes around the world are pointed at the same patch of sky. Space agencies on 6 continents are coordinating observations. An ancient object from another time, another place, another star is passing through our cosmic neighborhood, offering one final glimpse before disappearing forever into the darkness between worlds. Think about that for a moment. Let it sink in. If you've stayed with me through this entire journey through the science and speculation, the anomalies and explanations, the coincidences and the questions they raise, then I want to thank you. This is why I make these videos. This is why I spend hours researching, writing, trying to capture something true about the universe we inhabit. Because moments like this matter. They connect us to something larger than our daily concerns, something older than our species, something vaster than any individual mind can fully comprehend. 3 Atlas has been traveling for 7 billion years. It paused in our solar system for a few months, and then it will continue on toward whatever destination lies beyond the reach of any telescope we will ever build. We were lucky to see it. We were lucky to be here at this moment. With these tools, with this capacity to wonder, if this content meant something to you, please consider sharing it with someone who might appreciate it. Subscribe if you haven't already. Leave a comment telling me what you think, whether the coincidences we've discussed feel meaningful or merely random. I read every response, and your engagement shapes what I create next. Thank you for watching. Thank you for thinking. Thank you for being part of this community of curious minds, trying to make sense of a universe that never stops surprising us. The sky is dark tonight. The moon is new, and somewhere out there, getting closer every minute, an ancient visitor from another star is preparing to say goodbye. Good night. Everyone, keep looking up. Disclaimer. This video contains scientific information alongside speculation and theories that have not been confirmed by mainstream scientific consensus. The views expressed about potential anomalies and alternative interpretations represent ongoing debates within the scientific community. Always consult official sources from NASA, ESA, and peer-reviewed scientific publications for confirmed information about 3 Atlas and other astronomical phenomena.